Hey, geometries, this is Mr. Bloom again. Chapter 3 review. This is our Chapter 3 practice test. Our first question, identify the following in the diagram at the right. Two pairs of parallel segments. Now, there are a lot of pairs of parallel segments. Parallel segments can exist in the same plane, okay? And the way we write this, my red ones are parallel. And incidentally, so is MK is parallel to GI, and MK is also parallel to HF, because I could conceivably draw a plane that encompasses those. So I was supposed to come up with two pairs, and I showed you two, but there are a possibility of more. But I've got HF parallel to segment IJ, so the ones that I've actually written down are HF to IG, and HL, and I've got HL to IM. And there's multiples that we can come up with. Two pairs of parallel planes. Parallel planes are my front and my back, my top, my bottom, my left, my right. So when I come up with them, I've got parallel planes HFIG, and all I need is three letters for a plane, but HFIG. Okay, so I've got this, and I got LJKM, that I got this on the bottom. I also have plane HFJL, and that's this side plane, and IGKM, which is this side plane. So those are the ones that I have parallel to each other. And the only one I didn't do is the front plane and the back plane. Now, two pairs of skew segments. Remember, skew won't cross. Those are skewed to one another. They are not in the same plane, so they won't intersect, and they are not parallel. So HI and L and GK, so I will highlight HI and GK are skew. I will also highlight my other skew are LM and GJF. So if I take LM and JF, those are also skew. Now, looking at my next thing, I'm looking at my next figure here. Okay, so I'm looking at use the diagram at the right for exercise 4 through 7. Name one pair of each angle type. Alternate interior angles. Alternate interiors, I have to identify my transversal. Okay, and then I have the two lines that cross. Now keep in mind, these are not parallel. These are just the transversals crossing these two lines. Alternate interiors are 2 and 6, 7 and 3. Okay, so those are my alternate interior pairs, angle 2 and angle 6, angle 7 and angle 3. Same side interiors. My same side interiors are angle 7 and angle 6, and angle 2 and angle 3. They're on the same side of the transversal and inside the two lines that the transversal crosses. So angle 2 and angle 3 and angle 7 and angle 6. Corresponding angles. Now when I'm looking at corresponding angles, I'm going to use red here with corresponding. If I just think about lifting up this intersection and bringing it over to this other intersection. 8 corresponds with 6, 1 corresponds with 3, 2 corresponds with 4, and 7 corresponds with 5. Those are my corresponding angles. Now I'm supposed to identify the angle relationship between 2 and 6. Well, if I think about the angle relationship between angle 2 and angle 6, those are alternate interiors. So I have alternate interior angles. And remember, these things are totally and completely names of angles, even if they are not parallel or if I'm not proving them parallel. It's just that's what their names were in section 3.1. Now, in 8, I'm looking at angles, angle pair relationship when the lines are parallel. That's what this means right here, that these two lines are parallel. Okay, so in 8, identify 4 pairs of congruent angles. I can do any 4 pairs. I just can't do verticals because verticals are always congruent. I just want to make sure you know the others that aren't. So those are vertical. 1 and 4 are vertical. 7 and 6 are vertical. 5 and 8, all those angles are vertical. But I'm talking about parallel lines, and because of that, I'm talking about alternate interiors, alternate exteriors, and corresponding. Those are the things that will be, those are the things that the angle pair relationship names that I'm interested in, because those are the ones that are congruent. So if I'm looking at these, I've got angle 1 and 5. Angle 1 and 5 are corresponding. Angle 8 and 1 are alternate exterior. Angle 3 and 7 I've got with corresponding again. And angle 7 and 2 are alternate interior. But just to remind you, that's what I've got. when I'm doing them. You probably came up with other ones, but remember, it has to make sense with corresponding angles, alternate interior, alternate exterior, same, and they can't be same side because they wouldn't be congruent. But in 9, please look at 9, identify 2 pairs of supplementary angles, 2 pairs. Well, there are only 2 pairs of supplementaries. I got 4 and 7, and 2 and 5. Those are my supplementary angle pairs. Okay, and they'll add up to 180 degrees if I add them together because the lines are parallel. Now in measure of angle 4, if the measure of angle 4 in problem 10 is 125 degrees, what is the measure of angle 7? Since 4 and 7 are same side interiors, I know that relationship that angle 4 is plus angle 7 is 180 degrees. And that's because of same side interior angle theorem. But now I know angle 4 is 125, so I can substitute that in and solve for angle 7 by subtracting 125 from 180 and finding out that the measure of angle 7 is 55 degrees. Now that's page 1. Okay, we're going to go on to page 2 here. In page 2, state the theorem or postulate that proves A is parallel to B. Well, if I know these 2 angles are congruent to each other, and I'm using a converse of the theorem. Remember, when I'm proving lines parallel, I've got the converse. And the converse theorem, the converse of corresponding angles postulate, the converse of alternate interior angles theorem, the converse of alternate exterior angles theorem, and the converse of same side interiors angles theorem. Those are the things that are running through my head. And I've got to make sure I kind of put them together with the combination that's there in front of me. The 2 that I'm just moving out here, these are alternate interiors. So by the converse of alternate interiors, and I can say that in 11, and that's alternate interior angles theorem, I can say that those 2 lines are parallel, A and B. So A is parallel to B because of converse of alternate interior angles. Now, if I look at this one, and it's interesting, this and this are congruent, okay? All right, I don't know anything about y minus 10 and 100, but I do know those markings show that they're congruent, and those happen to be in a corresponding angles position. So by the converse of corresponding angles postulate, okay, by the converse of corresponding angles postulate, I know that A is parallel to B. Okay, so and that's all they asked me to do there. Now in 13, they ask us, what is the value of y for which A is parallel to B? And that's where those 2 values, the y minus 10 and the 100 come in. Those are actually, if I think about, those are corresponding angles in those positions. And if they are the same, then the lines are parallel. So I'm going to set them equal and find out the value for y to make A parallel to B. So if y minus 10 is equal to 100 because corresponding angles are congruent and therefore equal by definition of congruence, I'm going to add 10 to both sides and find out that y is equal to 110. So the value of y being 110 allows A and B to be parallel. When I'm looking at problem 14, what conclusion can you make about lines x and z based on the diagram at the right? Well, keep in mind, x is parallel to y. So I know that x is parallel to y. I also know that y is parallel to z. Well, since x is parallel to y and y is parallel to z, I know x and z are parallel, okay, because of transitive property of parallel lines. And that's pretty much what I've got. X and z are parallel because of transitive property of parallel lines. In 15, I'm dealing with triangle angle sum theorem. The 3 interior angles of a triangle add up to 180 degrees. So when I'm doing this, I'm thinking 62. Now maybe I should, write this out that I got the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. All 3 angles add up to 180 degrees in a triangle. So I got 62, 24, x. I add those together and I got 86, and I subtract, get 94. So the missing angle, the 3rd angle of the triangle, is 94. Now remember, I know this because find the measure of the 3rd angle of a triangle given the measure of 2 angles. Okay. All right, so 75 and 37 are 2 interior angles of the triangle. So 75 plus 37 plus x is equal to 180. Add them together, 112. Subtract, and I know x is 68, so I got 68 degrees. And my last one here, I got 19 and 45. I'm going to do this the same way. 19 plus 45 plus x is equal to 180. Okay, because all three interior angles of a triangle add up to 180 degrees. Triangle angle sum theorem. Now I just add 19 and 45 becomes 64. Subtracting 64, I find it's 116. So I got 116 degrees for my third angle. So that's triangle angle sum theorem. Now my next one is exterior angle theorem. Remember the exterior angle, the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. And I'm totally using that to get this done. So I've got that going. Excuse me. Those are my answers. I got that going on here. The measure of angle 1 plus the measure of angle is equal to the measure of angle 2 plus the measure of angle 3. Well, I know 2 is 37 and I know 3 is 99. I can plop those in and I find my total of 136. Well, if angle 1 is 136, the measure of angle 1 plus the measure of angle 4 are supplementary. Okay, so angle 1 goes in right there. Okay, and I can subtract that from 180 and come up to the measure of angle 4 as being 44. Now, if you had problems with this, give 19 a try on your own. If you've totally got it done, we'll go over the answer, but you got to turn me off if you're going to try it for the first time. Welcome back. Okay, again, we're doing triangle. We got a triangle with the exterior angle is equal to the sum of the two remote interiors. That's what we've got. So now I'm going to plug in the values I have. I got 98 goes in for angle 1 and 55 goes in for angle 2. I subtract that 55 to solve for angle 3, and the measure of angle 3 is 43 degrees. Now, I know 3 is 43, but the relationship between angle 1 and angle 4 is going to help me find angle 4. So angle 1, the measure of angle 1 plus the measure of angle 4 is equal to 180. Okay, and I know the measure of angle 1 already is 98. So I subtract that from 180 and find out that the measure of angle 4 is 82 degrees. Okay, that's the end of page 2. And we're going to move on here. In page 3, problem 20, we're asked here to find the slope of the line passing through the given points. Remember, slope is equal to y2 minus y1, x2 minus x1. Okay, if I use my points, I've got 4, 7, y's on top, 7 on the bottom, and I got 12, 5. Now I'm supposed to find their difference. And after I do that, I find out that my answer will be negative 8 on top, positive 2 on the bottom, and I've got a negative 4 for slope. So my slope here is negative 4. Let's check that out using my graph that they've provided. If I go down 1, 2, 3, 4, 5, 6, and over 4, 1, 2, 3, 4, okay, that's a different thing. Why isn't it the same? Because this is problem 21 and this is problem 20. Okay, so remember, slope is also rise over run. And I'm using my graph. I could totally use the formula I just did, but I'm going to use the graph, and I went down 1, 2, 3, 4, 5, 6, down 6, to the right 1, 2, 3, 4, over 4. So if I talk about rise down 6, right 4, and reduce it, I actually have negative 3 over 2 as my slope. So my slope is negative 3 halves. In 22, problem 22, when we're doing 22, what is the equation of the line with slope negative 2 and y-intercept 8? Now, I have a slope and an intercept. I have to be thinking this form. This is slope, this is intercept, and I wrote it wrong, plus b, intercept, and there we go. Okay, now in 23, what is the equation of line passing through the negative 2, 10, 4 and negative 6, 2? First on this one, must find slope. Find slope. Okay, so slope, we just found up there, y minus 2 minus y sub 1, y sub 2 minus y sub 1, x sub 2 minus x sub 1. And I have 4, negative 10, 2, negative 6, find slope to find their difference. And that's going to be 2 on top and negative 4 on the bottom, which equals negative 1/2. So that's my slope I'm going to use. I don't care whether you pick this one or this one. Now I have a point and a slope. So I'm going to use point slope form and plug it in. Y minus y1 equals mx minus x1. That's what I've got to use. So depending on how you plugged it in and which slope you used, those are your answers. Now, segment AB contains points A and B. Segment CD contains points C and D. Are segment AB and segment CD parallel, perpendicular, or neither? Find the slopes is our hint. So I got to find the slopes in 24, 25, and 26. And again, I am just using this slope theorem, this slope formula. Well, let's find this again. So slope, my formula for slope, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So I got to find the slope of AB. And the slope of AB, again, I got my formula to the right there. I go negative 8 is A over 3, and B is 2 over 0. I find their difference, and I find that this is negative 10 over 3. My slope of CD is going to be 6 over 5 and 3 over 2. Yep, 3 over 2. And I've got 3 over 3, and that's 1. So they're not opposite reciprocals, okay, because this slope is 1. They're not opposite reciprocals. They're not the same. Okay, opposite reciprocals are perpendicular. The same as parallel. So these are neither, okay, when I do that. My next one, I'm going to find the slope of AB. Okay, I'm going to do this on each one of them. Negative 9, 4, and negative 1, negative 2. Okay, and I am going to find their difference. And now I have negative 9 plus 1, which is negative 8. I have 4 plus 2, which is positive 6. And I also have a slope of CD. CD is negative 7 over 12 and negative 10 over 8, finding their difference. And I've got positive 3 up top, positive 4 on the bottom. Now, keeping in mind, I did not reduce the red up here. And this 2's into both of those, so this is negative 4/3. Well, these two are actually opposite reciprocals, and I can check to prove that they're going to be perpendicular because their product is equal to negative 1. So I've got that going, and they're perpendicular. So I'm going to do the same thing in 26 and 27. Okay, I'm going to shrink these down because I'm slowly running out of room. Okay, and we're going to do a different color. So I got the slope of AB, okay, which equals 2 over negative 3 and 6 over 5. And I find their difference, so I got negative 4 over negative 8, which is the same as positive 1/2. And then I got the slope of CD, and that's 6 over 7, 0 over negative 5. Find their difference, and I got 6 over 2. Okay, we made a mistake here. We got to go back. Hold on. We can't have that 3 be there. So when we go there, we got to make sure that when we put that in, we got to subtract that. So this is 6 over 12, and that is 1/2. I now know that these are parallel. Okay. Now, what is an equation of a line? Parallel lines have the same slope. That to y equals 2x plus 3, that decays 4, 6. Read your slope. Slope is 2. Okay, and then use your point. Y minus y1 equals m, x minus x1. Okay, now I've got this going on, and I've got my slope, my point, and I've got 2x minus 4, and I'm able to write that equation in. That should be it, and that's all I have to do. Or if I wanted to solve, because this is in point slope form right away, I can solve for y, and I can put it in slope intercept form. So that'd be y minus 6 equal 2x minus 8, and subtract or add 6, and that'll be equal to negative 2 for my slope intercept form. And my last one on this here is write an equation of line perpendicular to the provided line. Now, keep in mind, I'm going to give you equations to pull a slope out of. My perpendicular slope, however, is the opposite reciprocal of 3, so it's negative 1/3. And it's through this point. And again, y minus y1 equals m, x minus x1. Okay, once I do that, I've got y minus 5 equals negative 1/3, x plus 6 is my equation. And that's what I should be pulling up. Now, I've got some people going, wait, you didn't put it in all of a sudden I look, oh no, I didn't reread that it was slope-intercept form. Well, how do I get it there? Solve for y. So it's negative 1/3 x, and negative 1/3 of 6 is negative 2. I add 5 to both sides, and I get plus 3. Hey, wait, that's what we were supposed to find because it's in slope-intercept form versus point-slope form. Our last 4 problems. Determine whether the following pairs of lines are parallel, perpendicular, and either. Show your supportive work. This is already in point slope form, or excuse me, slope intercept form. So if I can get it to here, if I can read it from point slope form, it'll be easy. Now in the first one, I'm looking at 1/3 x, so I've got just to subtract 1/3 x on both sides. Okay. That looks like 1/3 x. Hold on, let me just check your stuff here just to make sure it's 1/3 x. Yeah, it's 1/3 x. It didn't come up real well, so it's 1/3 x. So I'm going to take y is equal to negative 1/3 x plus 8. So now I've got my slope and my slope. If I take these two slopes and multiply them together, I get the value of negative 1. So these are perpendicular lines. In this other one, I've got to do 2 solves. 2x plus 3y equal 5. And 3y is equal to negative 2x plus 5. Y is equal to negative 2/3 x plus 5/3 as I solve. That's the first one. The other one is 2y is equal to 3x plus 4. And I divide by 2, and y equals to 3/2 x plus 2. I read my slopes. Okay, and I find out that these are opposite reciprocals of each other, and proof is in the pudding when I actually multiply them together and find out that this also will be negative 1. So my lines are perpendicular. My last 2 problems here. Solve for the value of x. Pay attention to markings you have in the picture. These are parallel. Okay, this conceivably could be the transversal. I have 2 same-side interiors, and same-side interiors are supplementary. So I got 9x equal 180, and x is equal to 20. So this is 100, and this is 80, and we're checked. Okay, and in 32, I've got corresponding angles, and these are parallel. Okay, so if I'm looking at this in problem 30, and that is looking like 3p minus 6, equal 90, I add 6 to both sides, I get 96, and divide by 3, and I get 32, and that's my p-value when I'm done. If you have any questions, make sure you talk to your local geometry teacher, and have yourselves a great day.